Hello and welcome. In this video, we're going to be testing east to west communications on a network that we've built. So oftentimes you build a network and then the application guys come in and build their applications on it, especially in the data center. So you have a few firewalls, a few SVIs, and these will all connect to each other. And a lot of east-west connectivity, which means that the server in the inside will want to connect to one in a different DMZ, or between a connection broker, or between a VLAN. That sort of stuff is important. So if you have a database and the application happens to be on separate networks, or a SQL server, or anything really, we can have RDP, we can have network time, all that stuff on the network, and we want to check that it's connected. So we can specify a port and an IP address in these little applications we can create. We can put a Raspberry Pi pretty much anywhere on the network and run the server-side application or the client-side application, connect our computer to another segment, fire up both these programs, and then we should see if there's a success or not on those programs without actually having to use the client's programs. So what we're going to do is we're going to first create the one in the Raspberry Pi. So we're going to make a directory, and we're going to call it socket programs, and then we're going to cd into that as well. Okay, and then we're going to create the server side here. So it doesn't really matter which way you have it around. Just testing certain ports. So we're going to go nano, and then we call it server test.py. Cool. Now we've created that, we're going to add the code in. So this is not a programming tutorial. I've left the programs below. So there's a client one and the server side one, which you can just grab off the description. Okie doke. Let's just drop in the server side. Here we go. So we've got import socket, which is using the sockets library. We've got the host, and that's the host IP address of this this Raspberry Pi, and then the port. So port, I'm going to put is 443. Oops, we're in nano, so I need to actually go and edit it manually here. 443, and then exit, and then save. And then we want to make this executable, so we do this simply by doing this plus x, and we're going to program, and we'll see it come up as green or whatever color that you guys are scheme. Okay, and then we're going to run it. So we're basically going to go Python and then the program. This should, oh, no permissions, huh? We can sort that out with sudo. Okay, it's listening on this port, on port 443. So now we just need to do the Windows side. So what we need to do is put the client in. The client's going to try and initiate the connection, and this one's listening. So we're just going to pop this in here. Just get rid of that. So basically it's specifying an IP address again. This is the IP address of the server this time, and then the ports need to match. So I need to just change that to 443. So this client's going to try and initiate connection with this side of the network here. What we do is then run it. So we need to just, we've already got it running. So we just need to press start. And what we've got is a successful connection to the client, which is the string here. Actually, it's a string inside this one. And this one should say connection to the server, which is spelled wrong. Which is, yep, it's successful. So if you want to do create a quick application, you can do in Linux and Windows to connect end-to-end connectivity. That'll be the end of this video, and I'll see you on the next one. Take care. Bye bye.